So the next one is transitivity. So here there is no such pair of R where xy belongs to R and yz belongs to R implies xz does not belong to R. Therefore, R is not transitive. So the next one is relation R in set A is 1, 2, 3, 4, 5, 6 as R equal to xy such that y is divisible by x. Y is divisible by x in the sense when we divide y with x, the remainder must be 0. A solution. So here xy says that y divisible by x. So 1 comma 1 take it. So the relation is 1 is divisible by 1. Similarly 2 also. 2 is divisible by 2 till 6. 6 is divisible by 6. If we generalize that, x is divisible by x. Therefore, R is reflexive. The next one is symmetry. Here let us take 2 comma 4. 4 is divisible by 2. So change this as BA. 4, 2. 2 is not divisible by 4 exactly. So one case is failed. So other case also we'll generalize it. It is not satisfied. If it is satisfied or not satisfied, the remaining cases. So here AB belongs to R implies BA does not belong to R. Therefore, R is not symmetric. As per the definition of transitive relation, we have only one participle here. So let us take 6, 3, 1 as ABC. So the first case is A is divisible by B is divisible by A, or here it is mentioned xy. Let us take x. So if you take in this order x comma y, that means the first one is 3 is divisible by 1, and y comma z, 6 is divisible by 3. Therefore, check the third case, x comma z. So 6 is divisible by 1. Therefore, R is transitive. Here, why we did not consider the other elements? The other elements, when we are choosing it, it should satisfy this condition. xy belongs to R and yz belongs to R. Then we have to check out xz whether this belongs to R or not. The next one is relation R in the set Z of all integers defined as R is a set of xy such that x minus y is an integer. Solution. So reflexive. Here x minus y is an integer. So as per the reflexive definition of reflexive, x minus x equal to 0 is an integer. Therefore, R is reflexive. So next, symmetry. X minus y is an integer. So change this, y minus x. Y minus x also we can write it as minus of x minus y. When x minus y is an integer, so minus of integer is also an integer, either positive or negative. That means when x minus y is an integer, y minus x is also integer. So as per the definition of symmetry relation, AB belongs to R implies BA belongs to R. Therefore, R is symmetric. So next, transitive. So here x minus y is an integer. That is xy. Now if it is yz, so y minus z is also is an integer. Now when these two are satisfied, then check out x comma z. As it is mentioned, it is integers. So here x minus z is also an integer. Or if you want, you can take here xy values, xyz values are 1, 2, 3, some integers, any integers you can take, not only positive, negative, or 0 also. Still make it to understand, you can use the same values. Therefore, R is symmetric. Sorry, R is transitive. So the next question is, relation R in set A of human beings in a town at a particular time is given by. So here relation R is set of xy such that x and y work at the same place. So reflexive is x and y work at the same place. So x comma x, x and x work at same place only. Right? Therefore, R is reflexive. Symmetry. So let us check out xy. X and y work at same place. Then y and x also work at same place. Therefore, R is symmetric. Right? And for transitive also same. And transitive. xy. X and y work at same place. And yz. Y and z work at same place. Therefore, x and z work at same place only. Therefore, R is transitive. So the next one is R is set of xy such that x and y lie in the same locality. If you observe this question and previous question, the previous question same place is given, now it is same locality. So that it is directly we can say it is reflexive, symmetric, and transitive also. So as x and y live in the same locality, x comma x, such that x and x live in the same locality. Therefore, R is reflexive. So symmetry, xy, x and y live in the same locality. Right? So y and x also live in the same locality. Therefore, R is symmetric. Clear? Next, transitivity. X and y live in the same locality. So y and g live in the same locality. Therefore, x and z is also live in the same locality. Right? Therefore, R is transitive.